planet has worn many faces over billions of years. Imagine a world draped in thick ice sheets, then boiling hot oceans, and later dimmed by volcanic ash, all before anything more complex than a single-celled organism appeared. Climate change in one form or another has always been part of Earth's story, but what's truly new is the speed at which it's happening today. For most of Earth's history, these changes unfolded gradually, over millions of years, giving life time to adapt. Now something different is unfolding, and it's happening in the blink of a geological eye. In the last few centuries, humans, people like us, though maybe with different hats, began burning fossil fuels like coal, oil, and natural gas to power our lives. While our fashion has changed, our reliance on these fuels hasn't. Every year, we release billions of tons of carbon dioxide into the atmosphere. This massive output is driving climate change at a pace never seen before. What once took millions of years is now happening within a few human lifetimes, fundamentally altering the world we live in. I'm Dr. Sammy, your friendly neighborhood entomologist, and this is Crash Course Biology. Today we're diving into a topic that's heavy on the gases and light on the Golgi bodies. You might be wondering, what does climate change have to do with the science of life? The answer is everything. Life and climate are tangled together, much like those headphones you find at the bottom of your backpack. Tug on one and the other moves too. Let's untangle this relationship and see why climate is so crucial to life on Earth. Let's clear up a common confusion. Climate isn't the same as weather. Weather is what you experience day to day, like deciding whether to grab an umbrella. Climate, on the other hand, is the average of those weather patterns over many years. Knowing the climate helps you decide if you need an air conditioner, not just a raincoat. While weather might influence your outfit for the day, climate determines where and when different forms of life can survive. It's the long-term backdrop to all living things. The planet isn't just floating in space unprotected. It's wrapped in an atmosphere, a big invisible gassy jacket. This jacket is made up of different gases, and a small fraction of them are known as greenhouse gases. These special gases, like methane, water vapor, and especially carbon dioxide, are crucial because they absorb solar energy extremely well. Even though they make up less than half of 1% of the atmosphere, they play an outsized role in keeping Earth warm and habitable. When sunlight reaches Earth, most of it passes through the atmosphere and warms the planet's surface. Some of that energy bounces back towards space, but greenhouse gases trap a portion of it, bouncing the heat back down. This process is called the greenhouse effect. It's similar to how a greenhouse uses glass to trap heat inside, keeping plants warm. Thanks to this effect, Earth maintains a cozy average temperature of 14 degrees C. Without it, our planet would be a frigid minus 18 degrees C, great for ice cream, but not for life. Greenhouse effect is natural and essential, but it can go too far. When our atmospheric jacket contains more carbon dioxide, it becomes even better at trapping heat, sometimes too good. As things heat up, more water evaporates, and since water vapor is also a greenhouse gas, this creates a feedback loop. More heat means more evaporation, which means even more heat gets trapped. Unlike putting on extra layers for a hike, our planet can't easily shed this extra warmth, leading to a dangerous buildup. You might think our understanding of the greenhouse effect is new, but scientists have been studying it for nearly 170 years. Back in 1856, Eunice Foote, an American scientist, experimented with different gases in sunlight. She found that tubes filled with carbon dioxide heated up much more than others. Foote theorized that if Earth's atmosphere ever contained more carbon dioxide, the planet would warm up, a prediction that's come true today. Her work laid the foundation for our understanding of climate change. Eunice Foote's experiments were groundbreaking, especially considering the barriers women faced in science at the time. She filled glass tubes with different gases, placed them in sunlight and shade, and measured their temperatures. The tube with carbon dioxide soared to 51.7 degrees C, hot enough to burn your fingers. Foote concluded that an atmosphere rich in carbon dioxide would warm the planet. Today, her insight is more relevant than ever, as we see the effects she predicted playing out on a global scale. A few decades after Foote, Swedish scientist Svante Arrhenius connected the dots between burning coal and rising carbon dioxide. Coal, oil, and natural gas are fossil fuels formed from ancient plants and animals. When we burn them, carbon dioxide is released into the atmosphere. Arrhenius predicted that continued burning of fossil fuels could warm the planet within a few thousand years. However, our emissions have far outpaced his estimates, and the warming is happening much faster than he imagined. Fossil fuels are made from the decomposed remains of plants and animals that lived long before the dinosaurs. When we burn coal, oil, or natural gas, we're releasing carbon that's been locked away for millions of years. This process dumps huge amounts of carbon dioxide into the atmosphere. The more fossil fuels we burn, the more carbon dioxide we release, and the faster our climate changes. It's a cycle that's accelerating, with serious consequences for life on Earth. Since the Industrial Revolution, our emissions of carbon dioxide have grown dramatically. The mountain of evidence linking these emissions to global warming is overwhelming. While some oil and gas companies have tried to cast doubt on climate change, the scientific consensus is clear. We've only been measuring global temperatures directly since the 19th century, but even that short record shows a steady rise, about 1 degrees C since 1880, and that's just the tip of the iceberg. How do we know what Earth's climate was like before we had thermometers? Scientists read the planet's climate diary by studying ice cores. When snow hardens into ice, tiny bubbles of air get trapped inside. By drilling deep into polar ice, researchers can analyze these bubbles to see what the atmosphere was like hundreds of thousands of years ago. Ice cores reveal that carbon dioxide levels and temperatures have risen and fallen together for 800,000 years, until recently, when CO2 began to spike rapidly. Before the Industrial Revolution, there were about 280 carbon dioxide molecules for every million molecules of air. By 2022, that number had jumped to 422, the highest concentration in 4 million years. This surge in carbon dioxide is driving more than just rising temperatures. It's affecting every system on Earth, like pulling on a tangled mess of headphones and watching everything else in your bag spill out. The effects are widespread and interconnected, touching every corner of our planet. The ocean is Earth's largest carbon sink, a massive storage container for carbon. In fact, the ocean holds 50 times more carbon than the air or soil. But when carbon dioxide dissolves in water, it creates an acid. Since the 19th century, the ocean has become 30% more acidic due to this chemical reaction. This acidification threatens marine life and disrupts entire ecosystems, showing just how far-reaching the impacts of rising carbon dioxide can be. As greenhouse gases trap more heat, more energy is pumped into the planet. This extra energy doesn't just warm the air, it also heats the oceans, fueling stronger and more frequent hurricanes and typhoons. The entire climate system is thrown off balance, leading to more extreme weather events. These changes are already being felt around the world, from devastating storms to shifting seasons. As the planet heats up, spring arrives earlier, winters grow shorter, and summers stretch longer. These shifts in the seasons disrupt natural cycles, affecting everything from when flowers bloom to when animals migrate. Rising temperatures also lead to more frequent droughts and heat waves, drying out forests and turning them into tinderboxes for wildfires. The ripple effects touch every ecosystem on Earth. With hotter, drier conditions, forests become more vulnerable to wildfires. Dried-up plants serve as fuel, making fires spread faster, farther, and more often. These wildfires not only destroy habitats and homes but also release even more carbon dioxide, feeding back into the cycle of warming. It's a dangerous loop that's becoming more common as the climate changes. Earth's polar ice caps are melting at an alarming rate. Solid ice is turning into slush and seawater, causing ocean levels to rise and encroach on land. Some communities now face too much water while others struggle with too little. The melting ice is a clear sign of the planet's warming, and its effects are felt worldwide, from coastal flooding to habitat loss for polar animals. Climate change doesn't affect everyone equally. Its adverse effects often hit lower-income communities and people of color the hardest, layering on top of existing social inequalities. This makes climate change not just a scientific issue but also a matter of environmental justice. Addressing it means recognizing and acting on these disparities, ensuring that everyone has a voice in the conversation and a chance to shape the future. Climate scientist Nicole Hernandez Hammer saw firsthand how rising sea levels threaten Miami Beach's Latino communities. Despite being on the front lines, these communities were often left out of climate conversations. Hammer took action, moving into environmental outreach and education. Thanks to her efforts, these communities are now part of the conversation, planning and advocating for their future. Her story shows how science and activism can come together to create real change. Impacts of climate change are complex and interconnected. When we burn fossil fuels, we release greenhouse gases that drive sweeping changes across the planet. These changes affect life at every level, from the tiniest bacterium to the largest elephant and even us. It's all connected, like a web where pulling one thread shakes the whole structure. Understanding this web is key to finding solutions. One way to slow climate change is by investing in nature's carbon sinks, soils and forests. These natural systems pull carbon out of the atmosphere and store it safely in the land. Protecting and restoring forests, improving soil health, and supporting ecosystems are all crucial steps. By working with nature, we can help rebalance the carbon cycle and reduce the heat-trapping gases in our atmosphere. Slowing the impacts of climate change means breaking up with fossil fuels. This won't be easy, our societies and global systems are built around them. But it's a breakup we can't afford to avoid. Transitioning to cleaner energy sources, improving efficiency, and rethinking how we power our lives are all part of the solution. It's a big challenge, but one we must face together. Hold emissions in check, we need to invent new systems and work more efficiently within old ones. This means developing renewable energy, redesigning transportation, and reimagining how we use resources. It's about creativity and innovation, qualities humans have in abundance. We've sent people to space, built electric cars, and created technologies that once seemed impossible. Now, we need to apply that same ingenuity to solving the climate crisis. Tackling climate change isn't a solo mission. It requires cooperation on a global scale. Getting a whole planet's worth of people on board is no small feat. Anyone who's worked on a group project knows how tough that can be. But when faced with global crises, humans have a remarkable ability to come together, share ideas, and find solutions. Our creativity and teamwork are our greatest strengths. Throughout history, humans have shown incredible ingenuity. We've built cities, invented new technologies, and even traveled to the moon. Tackling climate change will require that same spirit of innovation. From electric cars to renewable energy, our ability to imagine and create is our best hope for a sustainable future. It's a challenge, but one we're uniquely equipped to meet. The only way through the climate crisis is together. No single person, community, or country can solve it alone. It will take all of us working, learning, and innovating side by side. By joining forces, sharing knowledge, and supporting one another, we can build a future where both people and the planet thrive. The journey won't be easy, but it's one we must take together. Our next episode will dive deeper into the world of living things and see how our rapidly changing climate affects every organism on the planet. From bacteria to elephants, no creature is untouched by these changes. Understanding these impacts is essential for finding ways to adapt and protect life on Earth. Stay tuned as we explore the intricate connections between climate and life. The series is produced in collaboration with HHMI Biointeractive, bringing together educators, scientists, and storytellers to make complex topics accessible. If you're an educator, you can find classroom resources and professional development related to these topics at biointeractive.org/crashcourse. Together, we're working to build a more informed and engaged world, ready to tackle the challenges ahead. Thank you for joining us on this journey through climate and life. Crash Course Biology is filmed in Indianapolis, Indiana with the help of a dedicated team. Our mission is to make science accessible and engaging for everyone. If you'd like to support our work and help keep Crash Course free for all, consider joining our community. Together, we can keep learning and growing. Let's recap. Earth's climate has always changed, but never this fast. Human activities, especially burning fossil fuels, are releasing greenhouse gases that trap heat and disrupt the balance of our planet. The impacts are far-reaching, affecting weather, oceans, ecosystems, and people everywhere. But by understanding the science and working together, we can find solutions and build a better future. Science helps us understand the causes and effects of climate change. From early experiments by Eunice Foote to modern climate models, research has revealed how greenhouse gases warm the planet. This knowledge empowers us to make informed decisions and take meaningful action. Science is our guide as we navigate the challenges of a changing world. Data from ice cores, temperature records, and atmospheric measurements give us a clear picture of how the climate is changing. These records show a rapid rise in carbon dioxide and global temperatures since the Industrial Revolution. By analyzing this data, scientists can predict future trends and help us prepare for what's ahead. Reliable data is the foundation of effective climate action. Feedback loops are processes that amplify or dampen changes in the climate system. For example, as the planet warms, more water evaporates, adding more greenhouse gases and causing even more warming. These loops can accelerate climate change, making it harder to control. Understanding feedback loops is crucial for predicting and managing the impacts of global warming. Ocean acidification is one of the less visible but most serious effects of rising carbon dioxide. The more CO2 dissolves in seawater, it forms carbonic acid, lowering the ocean's pH. This harms marine life, especially creatures with shells or skeletons made of calcium carbonate. Coral reefs, oysters, and many other species are at risk, threatening entire food webs and human livelihoods. Climate change is making extreme weather events more common and intense. Hurricanes, typhoons, heat waves, and droughts are all becoming more frequent. These events can devastate communities, disrupt economies, and put lives at risk. Preparing for and adapting to these changes is a major challenge for societies worldwide. Melting glaciers and ice caps are causing sea levels to rise, threatening coastal communities around the world. Flooding, erosion, and saltwater intrusion are becoming more common problems. Some areas may become uninhabitable, forcing people to relocate. Addressing sea level rise requires both mitigation and adaptation strategies. Climate change often worsens existing social inequalities. Vulnerable communities, especially those with fewer resources, are hit hardest by extreme weather, rising seas, and other impacts. Addressing climate change means addressing these inequalities, ensuring that solutions are fair and inclusive. Environmental justice is a key part of the fight against climate change. Communities around the world are taking action to address climate change. From local clean energy projects to grassroots advocacy, people are finding creative ways to reduce emissions and build resilience. These efforts show that everyone can play a role and that collective action can make a real difference. Nature-based solutions like restoring forests, wetlands, and grasslands are powerful tools for fighting climate change. These ecosystems absorb carbon, protect biodiversity, and provide benefits for people and wildlife. Investing in nature is a win-win for the planet and future generations. Innovation is key to solving the climate crisis. From new energy technologies to smarter cities and sustainable agriculture, creative solutions are emerging every day. Supporting research, investing in clean tech, and encouraging bold ideas will help us build a more sustainable world. Education empowers people to understand and address climate change. By learning about the science, impacts, and solutions, individuals and communities can make informed choices. Education also inspires the next generation of scientists, leaders, and innovators who will shape our response to the climate crisis. The climate crisis is urgent, but it's not hopeless. By working together, embracing innovation, and supporting nature, we can slow climate change and protect life on Earth. Every action counts, from reducing emissions to restoring ecosystems. The future is in our hands, and together we can make a difference. As we wrap up, remember, the only way through the climate crisis is together. Our creativity, cooperation, and determination are our greatest assets. By learning, sharing, and acting, we can build a future where both people and the planet thrive. Thanks for joining us on this journey. Let's keep moving forward together.